Okay, guys, so today we are learning about different forces at work when we are dealing with motion. And when we speed up, the net force and velocity are acting in the same direction. So if we were to look at this graphic or this picture right here, the person pushing the sled is applying a force and they're both going in the same direction, which would be the velocity and the net force are going in the same direction. Contrary to that, when things are slowing down, is that when the net force is opposite of the velocity, so they're going in opposite directions. So if we look at the graphic here, Newton's second law applies to when a sled slows down. The force of friction is pushing or holding that sled in place. The direction of motion or the velocity is still going the same way. It's slowing the sled down. It's basically you guys, this application happens every day in many things that you do. When we turn, a force is applied that originally wasn't very well understood, but we know that net force acts on things that are turning at an angle. So, for example, when things are turning, they want to go straight. That object wants to go straight when turning, but the angle of the force pushes it into a turn. Okay, now there is a force in circular motion called centripetal force. And so centripetal force is constantly, the direction of motion in something when something's being spun is constantly changing. This means that when you spin something, there is constant acceleration going on. Prior to Newton's discoveries, we didn't quite understand, but there is a force that is acting upon something that's being spun called centripetal force. And the reason we know that is because when we spin things, we know that there is a pull or a push away from things. And that it's a non-zero force that's acting on that. If it were a net zero force, it wouldn't be moving. Centripetal force, basically what's happening in centripetal force is that this object here, if you look at my cursor, is pushing in towards the center of that shape. Now, if I were to let go of this, that ball would continue going in the direction this way because this force is pushing it outward.